Alright, so we are still under the addition of vectors, and we want to look at adding inclined vectors. Adding inclined vectors. Now, adding inclined vectors, that is to say, we have two vectors that are inclined to each other. Two vectors that are inclined to each other, meeting at a point, making an angle, let's say angle theta. How do you find those angles? Or if you have an angle that is inclined, two angles that are inclined, how do you find, or how do you add these two vectors, two vectors that are inclined, how do you add them? Now, there are many ways of doing that. One, we can use the parallelogram law of vectors. The parallelogram law of vectors. Two, we can use the triangular law of vectors. Three, we can use the resolution method. And four, we can use a graphical method to add these vectors. So now, if you want to add vectors that are inclined to each other, you can use any of these procedures: the parallelogram law, the triangular law, resolution law, or the graphical method to do it. Today, we want to look at the parallelogram law of vectors. We want to look at the parallelogram law of vectors. Now, what does this mean? The law states that if you have two vectors acting at a point, so let's say you have these two vectors which are inclined to act each other, and these two vectors are acting at a point which is represented both in magnitude and in direction. It's acting at this point. By adjacent sides of a parallelogram, their resultant vector will be represented both in magnitude and direction by the diagonal of the parallelogram drawn from the point. So what happens is that if there's two vectors, if they are acting at a point, both magnitude and direction, by the adjacent sides of the parallelogram, so these are the two vectors. Let's say this vector is V1. Let me draw it to all. And this vector is V2, which is represented this way. Then we can say these are the adjacent sides. So the adjacent side of vector V2, and this becomes the adjacent side of vector V1. Now, if you add the adjacent sides of this to form the parallelogram, what happens is that the resultant vector will also be represented both in magnitude and direction. So this is how we represent the resultant vector in magnitude and direction by the diagonal of the parallelogram. And this is the diagonal of the parallelogram. So this is the diagonal. So if you draw the diagonal of the parallelogram from the point which they are acting, then that becomes the resultant vector. This becomes the resultant vector. And always, it is also represented both in magnitude and in direction. So the resultant vector V becomes this one. Now, the moment you have this resultant vector V, what happens is that if you want to find the resultant vector, they will act at an angle. So for instance, these two inclined vectors, V1 and V2, they were acting initially at an angle of theta. And now we incline them at this very angle. Now, if you do this, the parallelogram, there's a way we can find the angle here. And let's say this angle is angle alpha. Let's say this angle here is angle alpha. So when you complete the parallelogram and you're able to find the angle here, we can now use the cosine rule. So you can now use the cosine rule to find our resultant vector. We can now use our cosine rule to find our resultant vector. And here, what is the cosine rule? So using the cosine rule, the resultant vector V is calculated as, so cosine rule. So now we can put this diagram here down, which is the resultant vector V, and we have our V1, and we have here as well our V2. So can you see it? Please, these two angles, they are also inclined at a certain angle. They are not 90 degrees. Otherwise, you have just used the parallel vectors. Adding parallel vectors. So they are inclined at this angle, which is the alpha over here. So now, then our V squared becomes our V1 squared plus our V2 squared minus 2 multiplied by V1 V2 cos of the angle that is opposite the resultant vector, cos of the angle that is opposite the resultant vector, or cos of the angle that links the two vectors together, and that is called alpha. Take note, it will always start initially at a certain angle, but after drawing the parallelogram, you get another angle which is alpha. I'll teach you how to get this angle because there's a law of parallelogram. There's a law of parallelogram. So that means this angle and this angle should be equal to what? 180 degrees. So the alpha plus the theta plus the alpha should be equal to what? 180 degrees. So that's the trick. So when they give you a 60 degrees, that means automatically this angle yields what? 120 degrees. That is the trick. And after use your law, this law to find it. So if you want to find the resultant vector V, that becomes the square root of V1 squared plus V2 squared minus 2 V1 V2 cos of what? Of alpha. And that is how we find the resultant vector. Okay, so that's parallelogram law. Let's take an example. And let's see how we can do it. Alright, so this is a question. And the question says that two forces, 6 Newton and 12 Newtons, inclined at 60 degrees to each other, act at a point. Find the resultant force. You have to find the resultant force. So here, the resultant force is very simple. These are the two forces here, 6 Newtons, and the other one is what? 12 Newtons. They are all inclined at a certain point, 60 degrees to each other. 60 degrees to each other. How do you find the resultant force? Using parallelogram law of vectors. So therefore, we have to draw the adjacent side, which is also here 12 Newtons, to complete the curve. Sorry, the parallelogram. And we take the diagonal, meeting at the same point. So this is F1 and this is F2. So therefore this is the resultant force F. Now when you do that, the angle here is very simple. It's 120 degrees because 60 plus the alpha here should be equal to 180, and alpha becomes 180 minus 60, which is equal to 120 degrees. Okay, so getting that, we can redraw our structure as this way. So this is our 6 Newtons, which is equal to our F1, and our F2 is equal to 12 Newtons, and our angle here is what? 120 degrees, and this is our resultant force. Okay, so getting this as our resultant force, then the question now becomes very simple for us. So now, our resultant force here now becomes the square root using cosine rule, F1 squared plus F2 squared minus 2 F1 F2 cos of the angle 120 degrees. So therefore, we get our F to be equal to the square root of 6 squared plus 12 squared minus 2 times 6 times 12 cos of 120 degrees. Now, if you use the calculator to find this, you'll be getting F is equal to root of 36 plus 144 minus negative 72. And you get F is equal to root of 252. And finally, the resultant force will be 15.87 newtons. So this will be your resultant force, which is 15.87 newtons. Let's go into other videos as we talk about triangular law of vectors. Bye.